gravitational field. So let us try to understand this one by taking some examples. Otherwise, you cannot understand this one. And whatever concept we are understanding here, same analogous concept we will study in current electrostatics also, as well as in magnetism also. Whatever concepts we are deriving, same type of equations you will get in electrostatics as well as in magnetism also. So the format of equations also, they will remain same. Akka, namaskar. Okay, ma? So listen very carefully, ma. Because same concept repeats two more times. So see. So this is a main mass, or you can call it as mother mass. Okay, ma? Whose mass is capital M. And from this main mass at a distance of x at a point P, there is one test mass. Okay? What is meant by test mass? A very small mass when compared to mother mass is called as test mass. For example, if it is Earth, this is an apple. Are you able to understand? Earth is a very big body, apple is a very small body. So that is why it is called as a test mass. Are you able to understand? Or you can call it as unit mass, or whose mass you can call it as approximately 1 kg. If mass of Earth is 6 into 10 power 24 kg. Are you able to understand? Okay, now see. So this main mass, it will exert some force on this test mass. And what kind of force it will exert? Gravitational force. And gravitational force is always attractive force, no? Always attractive force. So therefore, the direction of force experienced by the main mass on test mass will be in which direction? This will be the direction of force experienced by the test mass because of main mass. Okay? So gravitational force is always attractive. Are you able to understand now? So therefore, this is the direction of force, Fg. Okay? Now therefore, at this point, I will define gravitational field. Okay, ma? So what is Eg? Eg is nothing but Fg divided by test mass. This is called as Eg. And what is meant by Eg, ma? Eg is nothing but, already we have written, no, gravitational field. So by looking at this equation, how can you define gravitational field, ma? Define, cheyandi. How can you define gravitational field? So at this point, gravitational field is how much? Eg. At this point. Clear, ma? So therefore, how can you define gravitational field at that point? Because of the main mass. How can you define? So force experienced. ఏం చేస్తా ఉన్నారా? వినాలి కేర్ఫుల్గా. అర్థమవుతుంది కదా? నోట్స్ రాసుకోవడానికి కాదు క్లాస్ ఇది. వినండి, అర్థం చేసుకోలేకపోతే మీరేం లాభం లేదు. క్లాసులకు వచ్చి కూడా పెద్ద లాభం లేదు. ఇంట్లో బోకులు తోమడం లేదు దానికన్నా. ఓకే? బోకులు తోముకుంటే బోకులు తోమడంలో ఎక్స్పర్ట్ అవుతారు. స్కూల్కి వచ్చి వినకపోతే ఏమొస్తుంది? ఏమీ రాదు, టైం వేస్ట్ అవుతుంది. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఓకే, నౌ సీ. So therefore, at this point, how can I define gravitational field? Force experienced per unit test mass is nothing but gravitational field. So a unit test mass, it will experience how much force. And who is giving that force? That force is given by the main mass. So that force experience divided by what? Divided by the test mass, which is experiencing the force. Who is experiencing force? Test mass. Who is giving the force? Main mass. Are you able to understand? So force experienced per unit test mass is called as field at that point, gravitational field at that particular position. Are you able to understand? So therefore, how can I define this one? Therefore, force experienced per unit test mass at a point is called what? Is called gravitational field at that point. Okay, ma? Now let us try to understand this one by taking one more example. Before that, I will write the equation of gravitational force. See ma here. So what is the gravitational force existing between these two bodies? This is a sphere type of body, no? This is what kind of body? Sphere type of body. So sphere type of bodies always behave like a point mass. Already I said, you know. Sphere type of bodies, spherical bodies or circular bodies, they always behave like a point mass. So this is also a point mass. Test mass is also a point mass. So what is the distance between them? Distance between them is x. Then what is the force of attraction between them? F is equal to g m1 m2 divided by r square. This is the equation, no? Newton's law of gravitation. Now substitute the values. So G, one mass is capital M, another mass is test mass, and the distance between them is x square. That's all. This is the equation of gravitational force. Okay, now see. Therefore, okay, so therefore, what is gravitational field at this particular point? Gravitational field formula, gravitational force divided by test mass. That's all, Nama. What is the magnitude of gravitational force? G capital M into test mass divided by x square multiplied by m naught. So m naught, if you get cancelled, then gravitational field at that point is gm divided by x square. So this is the equation of gravitational field at this point because of what? Because of the main mass. Okay, ma? Now if you look at this equation, this is exactly the equation of acceleration due to gravity also, no? Acceleration due to gravity equation derive chesnam kada manam. What was that equation? Gm by r square. Are you able to understand? So here also for gravitational field also we got the same equation, no? So what do you understand? At a particular point, what is the gravitational acceleration? Same is the gravitational field also. Both are one and the same. Are you able to understand? So therefore what we say? Therefore, acceleration due to gravity at a particular point is nothing but what, ma? Is nothing but gravitational field at that point. Okay. Now you got understood how to calculate gravitational field, no, ma? So force experienced per unit test mass. In electrostatics in second year, same equation how we study. Electrostatic field is equals to force experienced per unit test charge. So in electrostatics, instead of mass we take charge, but here instead of charge I will take mass. That is the only difference, and equations, everything, they will remain same. Understood, no? Now see. So therefore at a point G value is same equation, gm by x square, and that is equal to exactly gravitational field also. So therefore gravitational field and acceleration due to gravity, they are analogous to each other, both are same. Is it clear? Okay. Now see. Now listen very carefully. See, ma'am. For example, if I take a main mass, capital M, okay? So here I am taking one point. So this point, let it call it as P. And I am taking one more point. I will call it this point as Q. Okay, listen very carefully. So this point P here, the gravitational field is E1, and here the gravitational field is E2. Now can you say E1 is greater or E2 is greater or both are same? To answer that question, this total discussion you should have listened very carefully. Otherwise you cannot answer. Are you able to understand the question, ma? So we are taking 2 points, point P, point Q. At point P the gravitational field is E1. At point 2 gravitational field is E2. E1 is bigger or E2 is bigger? Equal. Huh? No. E1 is bigger. How can you say? Distance is lesser, no, ma? See, ma, here, what is meant by E? This basic definition you should not forget. Okay? E is nothing but force experienced per unit test mass. And if you see the equation of force is inversely proportional to distance, no? Force is directly proportional or inversely proportional? Inversely proportional, no, ma? So it means what? If x value increases, force decreases. If x value increases, force decreases. So I can write here, gravitational force is inversely proportional to 1 by x square. It means if x value increases, gravitational force decreases. And if gravitational force decreases, Eg also decreases. That's all, no? If force is greater, then only gravitational field is greater. Force decreases, gravitational field also decreases. Understood, no? Therefore, P and Q, out of P and Q, which is at a lesser distance? Point P is at a lesser distance. This is at a distance of R1, and let us consider this is at a distance of R2. Definitely R1 is less than R2. Therefore, F1 is greater than F2. Therefore, E1 is greater than E2. Why? Because F is inversely proportional to 1 by R square. Okay, ma? And E is directly proportional to F. Is it clear? అర్థమవుతుందా ఏం డిస్కషన్ చేస్తున్నాము? నో, యాజ్ ద డిస్టెన్స్ ఇంక్రీజెస్ G వాల్యూ రెడ్యూసెస్, నమ్మా. మెయిన్ ఛార్జ్ నుంచి మీరు దూరం పోయే కొద్ది, మెయిన్ మాస్ నుంచి, వాట్ హ్యాపెన్స్ టు G వాల్యూ? G వాల్యూ రెడ్యూసెస్. దట్స్ వాట్ వీ హ్యావ్ స్టడీడ్ ఇన్ ద లాస్ట్ క్లాస్, నో? యాజ్ యూ గో అవే ఫ్రమ్ ద సర్ఫేస్ ఆఫ్ ఎర్త్, G వాల్యూ ఇంక్రీజెస్ ఆర్ డిక్రీజెస్? G value decreases, same concept here also. If G value decreases, E value also decreases, because E and G both are same. E means electric field, gravitational field. G means acceleration due to gravity. Both are one and the same, already we have studied, no? Are you able to understand, ma? So therefore, this point is closer when compared to this point. E1 point or point P is closer when compared to point Q. So therefore, if you place a test mass here, okay, ma? At point P, if you place a test mass, and same test mass you are placing at point Q also, then which test mass will experience more force? ఎక్కువ ఫోర్స్ ఏది ఎక్స్పీరియన్స్ చేస్తుంది? అట్ మాస్ అట్ పి, పాయింట్ పి ఆర్ పాయింట్ క్యూ? పాయింట్ పి, బికాస్ డిస్టెన్స్ ఈస్ లెస్సర్. If it is experiencing more force, field also will be greater. That's all, Nama. So that is why I can say distance is lesser, so force will be greater. If force will be greater, gravitational field also will be greater. So that is the definition of gravitational field. Force experienced per unit test mass. Understood, Nama? Now let us take one more example. See, ma. For example, this is a mass, capital M, okay, ma? And if I draw a circle or a sphere, consider this is a sphere, okay, ma? This is a sphere. On the sphere, if I take any point, let us call this is point P, this is point Q, and this is point R, okay, ma? So all of them, they are present at a distance of x, okay? Now can you say where gravitational field will be greater? Point around this main mass or mother mass, we are drawing a sphere. Okay, imaginary sphere ni draw chesam. We have drawn one imaginary sphere. Now on that sphere, I have taken some points, point P, point Q, point R. Okay, ma? At which point gravitational field will be maximum? ఏ పాయింట్ దగ్గర గ్రావిటేషనల్ ఫీల్డ్ మ్యాక్సిమం ఉంటుంది? మరి అది చెప్పండి మరి గట్టిగా, అంత డౌట్ ఎందుకు? అట్ ఎవ్రీ పాయింట్ సేమ్ గ్రావిటేషనల్ ఫీల్డ్ విల్ బి ఎగ్జిస్టింగ్, బికాస్ డిస్టెన్స్ ఆఫ్ ఎవ్రీ పాయింట్ ఈజ్ సేమ్, నో? ఓకేమా? సో డిస్టెన్స్ ఆఫ్ దిస్ పాయింట్ ఈజ్ ఆల్సో ఎక్స్, దిస్ ఈజ్ ఆల్సో ఎక్స్, దిస్ ఈజ్ ఆల్సో ఎక్స్. ఇఫ్ డిస్టెన్స్ రిమైన్స్ సేమ్, force also remains same, because main mass is also same, test mass is also same. Are you able to understand, ma? So therefore, I can say that force on test mass at point P is equals to force on point mass at point Q is equals to force at point R. If forces are equal, then field at point P is equals to field at point Q is equals to field at point R. So at every point you will experience same field. Are you able to understand, ma? So we will write many equations of a field, ma. But this basic formula students will generally forget. And what దీన్ని బేస్ చేసుకునే క్వశ్చన్ ఇస్తాడు. ఓకే, అర్థమవుతుంది కదా? విపరీతంగా ప్రాబ్లమ్స్ చేసి లాస్ట్కు ఈ అంటే ఏంటంటే ఈ అంటే ఏందో ఇప్పుడే 100 ప్రాబ్లమ్స్ చేసింటాడు ఫ్రెష్గా. ఈ అంటే ఏందో గుర్తులేదు సార్, పైతి పై వాడు చేసి ఏమీ లాభం లేదు. బేసిక్ డెఫినేషన్స్ యూ షుడ్ నెవర్ ఫర్గెట్. ఫోర్స్ ఎక్స్పీరియన్స్డ్ పర్ unit test mass, that is called as field. Are you able to understand, ma? అర్థమవుతుందా ఎలా ప్రొసీడ్ అవుతున్నాము? దట్స్ ఇట్. ఓకే మా, దట్ పాయింట్. సో వాట్ ఈస్ ద నోట్ పాయింట్ ఐ హ్యావ్ టు రైట్, మా? నోట్ పాయింట్ ఈస్ దట్ as we move away from main mass, okay, gravitational field continuously decreases. Gravitational field continuously decreases. Okay, that is the point. Masses can be present, you know. Point masses can be there, spheres may be there, solid spheres, hollow spheres, disk will be there. So all of them we will study. So there are many applications, but we will study only up to Neet and mains levels only. In advanced level you will have many applications, okay, which requires calculus for calculation. సో మన ఫేసెస్ ఇప్పుడు అంత లేదు కదా, జస్ట్ వీ విల్ స్టడీ ఓన్లీ అప్ టు మెయిన్స్ అండ్ నీట్ లెవెల్స్ ఓన్లీ. సిమా పాయింట్ మాసెస్. సో వాట్ ఇట్ మెంట్ బై పాయింట్ మాస్? దిస్ ఈస్ అ పాయింట్ మాస్, నో? పాయింట్ మాస్ మీన్స్ ఇట్ ఈస్ హ్యావింగ్ మాస్ బట్ ఇట్ డజంట్ హ్యావ్ ఎనీ ఏరియా, ఇట్ డజంట్ హ్యావ్ ఎనీ వాల్యూమ్. దట్ ఈస్ కాల్డ్ యాజ్ ఎ పాయింట్ మాస్. ఓకే, సో లెట్ ఇట్స్ మాస్ ఈస్ క్యాపిటల్ M. సో అట్ ఎ డిస్టెన్స్ ఆఫ్ R, ఓకే మా, హియర్ if I have a point P, at this point P I want to calculate a gravitational field. Okay, Now already we have a formula, Nama. What is the formula for gravitational field? E is equals to force experienced per unit test mass. That's all, Nama. So therefore what I will do here, I will place a small test mass. Okay, and test mass is very small when compared to this capital M. Test mass ante meaning main mass tho compare cheste test mass will be very small mass, because this test mass, it should not disturb the gravitational field of main mass. Main mass యొక్క gravitational field అనేది disturb చేయకూడదు, so that test mass is very small. Okay, now see. So gravitational field G m1 m2 divided by r square divided by m0. This is the formula, no? So therefore G, what is first mass? Capital M. Another mass is test mass divided by distance is r square multiplied by test mass. So m0 if you get cancelled, so Eg is equal to gm divided by r square. So this is the equation for gravitational field because of point mass. Understood, Nama? Previously also same equation we have got, no? Here also I am getting the same equation. Okay, and this is exactly equal to acceleration due to gravity also. Already we discussed, no? So from the main mass at a point P, what is the gravitational acceleration? Same will be the gravitational field also. So gm divided by r square. For field also same equation. For acceleration due to gravity also same equation. Okay. So then we study about hollow sphere. Hollow sphere, or you can call it as a shell. Okay, ma? Hollow sphere is also called as a shell also. Hollow sphere, football is an example of a hollow sphere, no, ma? Tennis ball, plastic balls, this ball, this is an example of a sphere. Okay, ma? Which kind of sphere? Hollow sphere. So mass is present only on the surface area. Inside this one everything is hollow. So this is an example of a shell. Okay, now let us see, ma. So on this shell I will take 3 points. Okay, ma? Shell of mass capital M. Okay, so every distance should be measured from the center itself, ma. Okay, so I will take 1 point exactly on the sphere. Okay, ma? I will take 1 point outside the sphere, and I will take 1 point inside the sphere. Okay, ma? Let us call this is point P, this is point Q, and this is point R. So at 3 points I want to find out gravitational field because of the sphere. Okay, now let us take the first point at point P. Let us consider this is at a distance of R, and its radius is capital R, ma. So this is at a distance of R, and this inside this sphere also I can call it as distance of R only. Okay, now see. So point P. Okay, so for outside points, spherical bodies behave like point masses. Okay, ma? For outside points, that is, this is an outside point, you know, ma? For outside points, how the spherical bodies behave? Spherical bodies means solid sphere also, hollow sphere also, shell also, everything is a spherical body. So every spherical body behaves like what? They behave like point masses, as if total mass is concentrated at their geometrical center. Okay, ma? So it means I can assume that this total mass is present here only. So here capital M is present. I can assume like that. So that is the beauty of spherical bodies. Are you able to understand? And therefore, how can I calculate a gravitational field, ma? So therefore, gravitational field is equals to force experienced per unit test mass. So for example, here if I place a test mass, clear, no? Gravitational field divided by test mass. So gravitational field is how much, ma? G capital M into M0 divided by R square multiplied by M0. So M0 get cancelled. So Gm divided by R square. Same equation. So what is the equation for point mass? Same is the equation for hollow sphere or shell also. But which point? For which point? For outside points. Outside points ki the point mass lage behave chestund. And where this total mass is present, ma? Exactly at its center. Okay, so total mass is assumed to be where? At its center. Total mass ekkada unnatluga manam anukovachu, exactly at its center. Okay, now let us take second point, point Q. Okay, ma? For points on the sphere, on the sphere behaves like point mass, concentrated at its center. Are you able to understand, ma? It means for point mass also, for points present on the sphere also, again sphere behaves like a point mass. Are you able to understand? And again where mass is concentrated exactly again at its center. So therefore, now this is the second one we are calculating. Now here at point Q, you place a test mass. Okay. Now main mass capital M is present at the geometrical center. Now what is the distance between both of them? Capital R, no? Okay, ma? Outside points kuda idi point mass lage behave chestundi. And for points present on the sphere also it behaves like a point mass only. Okay. Therefore, gravitational field at point Q is how much, ma? It is gravitational force divided by test mass. Gravitational force is G capital M into M naught divided by distance is capital R, no? Multiplied by M naught. So M naught get cancelled. So gravitational field at point Q is how much, ma? It is Gm divided by capital R square. Same equations. For this one also same equation, this one also same equation. Understood, no? అర్థమవుతున్నాయి కండిషన్స్. కేసెస్ అన్నీ కేర్ఫుల్గా గుర్తుపెట్టుకోవాలి. ఓకే, నెక్స్ట్ లెట్ us see. So next one is inside sphere. Third point is point R. This R. Point R. Okay, ma? Where it is present inside the shell or hollow sphere. Okay. Now listen very carefully. See, ma, here. Now this particular point R, where it is present? It is present somewhere here, no, ma? It is present at point R at a distance of R. Okay. Listen carefully. Now, if I place a test mass here, main mass is capital M, no, ma? This is a shell, hollow sphere. So this is a test mass placed at point R at a distance of R from the center, origin O, or 0, 0. Are you able to understand, ma? Now this test mass will experience force because of this total shell, no? Are you able to understand, ma? For example, if I take a small differential mass, dm, small differential mass. This differential mass, it will attract this m naught, no, ma? Similarly, here also there is one differential mass dm. This will also attract this one. Similarly, here also there is one differential mass dm. This will also attract this one. Here there is a differential mass dm. This will also attract this one. Here there is one differential mass dm. This will also attract this one. Okay, ma? Here there is one differential mass dm. This also will attract this m naught. Okay. And all these masses dm's, they are attracting this f naught, attracting this test mass, such that, okay, ma? So all differential masses are attracting the test mass such that net force on m naught will become 0. Okay, ma? What is the total net force acting on the test mass, ma? There is no net force because it is being pulled by differential masses on every direction, no? ప్రతి ఒక్కటి లాగుతూ ఉంది దాన్ని. ఏ వైపు పోతుంది అది పాపం? It cannot go anywhere. So net force on that will become how much? 0. If net force becomes 0, gravitational field also will become 0. Clear, no? So therefore, gravitational field at point R is equal to how much, ma? Gravitational force divided by test mass. So 0 divided by test mass is 0. Okay. So this is a very important point which you should remember, ma. So therefore, inside any shell, gravitational field is always 0. అది ఏదైనా కానివ్వండి, football or any other body, gravitational field because of that particular shell will be how much? 0. There is no gravitational field. Understood, Nama? So make a note of that point. Okay. So therefore, note point which we have to write is inside any shell, inside any shell, gravitational force, or we can say net force, becomes 0. So gravitational force also will be 0. Okay, ma? So gravitational force for inside of what? Inside of shell is how much? It is 0. Understood, no, ma? So on the outside of the surface, it is gm by small r square. On the surface, gm by capital R square. Inside the shell, it is completely 0. Understood, no? Therefore, if I draw a graph of distance from center versus gravitational field, then I have to draw the graph like this. Let us see how we can draw the graph. Understood, no, ma? So we are drawing the graph between which points, ma? We are drawing the graph between distance from the center of this hollow sphere and the gravitational field. This graph was asked many times in the previous examination. In 2020 also, same question was given. Okay, direct graph it is not in Neet examination. So let us see how we can draw the graph. See, ma? So this is a shell, or you can call it as hollow sphere. This is the center of the shell. Okay, ma? And from here, if I take the graph, okay, so on y-axis I will take gravitational field, and on the x-axis I will take r. What is meant by r here? Distance from center. Distance from center of shell. Okay, ma? And what is this point, ma? This is the point which is present at a distance of capital R, because radius of this shell is capital R, no? Okay, ma? Then the graph which I have to draw is like this. This is the graph. Okay. Now can you say, what do you understand by this graph? Ee graph chuste meekem artham avutundi? From where? From center or from the surface? No. From the surface of the sphere. Then what about from center to surface? This is the center of this gravitational field, no, ma? This is the surface of the gravitational field. What about from center to surface? There is no graph. Graph ekkada undi akkada? You have only dotted lines only. Graph is not there. This is the graph. It means here gravitational field is how much? 0. Lopala asalu gravitational field undadene intasepu manam attukunindi ikkada. Gravitational field is not there. Okay? So on the surface it is maximum. On the surface of the sphere, E value is maximum. From here it is continuously decreasing as E is inversely proportional to R square. E is inversely proportional to R square, no, ma? So field is continuously decreasing. Understood? No? But where it is maximum? At the surface, suddenly it becomes maximum. Okay? Because at the surface, what is the equation? At the surface, equation is E is equal to gm by capital R square. Okay, ma? For outside points E is equal to gm by small r square. And definitely small r is greater than capital R, no? For outside points, capital R is only on the surface. Small r is for outside points. So capital R is less than small r. So if denominator is smaller, total value will be bigger. If denominator is smaller, total value will be bigger. So you will have maximum field at the surface. Inside it is 0. Outside it continuously decreases, because E is proportional to 1 by R square. Understood, no, ma? So that is the discussion about hollow sphere. Okay? Right now. Okay? So next we will discuss about gravitational field because of solid sphere. Okay, ma? First make a note up to here. So see. So next we are discussing about solid sphere, ma. Previously we discussed about shell, where mass was not there. But here inside, throughout the volume also we have mass. Akada there mass was present only on surface area, but here mass is present throughout the volume of a solid sphere. Clear? So again I am taking 3 points, ma. 1 point out of the sphere, 1 point on the sphere, 1 point inside the sphere. Okay, ma? So out of the sphere, outside sphere, see, it behaves like a point mass, already we discussed, you know? So therefore gravitational field at point P is how much? It is gm divided by R square. That's all. No need of again calculation. Okay. Similarly, for on the sphere. On the sphere also it behaves like a point mass only, no? So again a point field at gravitational field at point Q is how much? Gm divided by capital R square. Same equations. But the problem comes when you take a point inside the sphere. Okay, ma? Inside the solid sphere. Okay. So let us take the diagram of this one. See, ma. Listen very carefully. So this is a solid sphere, okay, ma? And somewhere here at a point R, I want to find out gravitational field. Understood, no? Okay, so listen very carefully. Ma. What I will do is, by enclosing this point, okay, ma? I will draw one circle like this. Or I will take a smaller sphere up to this much of radius. Are you able to understand them? Now here, figure has divided into two parts. Figure is divided into two parts. What are the two parts? So here you have an outer shell and there is one inner solid sphere. Rendu parts ga ee figure ni manam divide chestunam. Ededi outer shell and inner solid sphere. Clear na ma? So therefore, we calibrated the solid sphere into a shell, or you can call it as outer shell, and inner solid sphere. Okay, ma? Which is the outer sphere here? This sphere which you are seeing, no? This sphere. This is the shell. This shell lage panchestundi kada? Because inside of this there is no mass. So that behaves like a shell. Okay? And this one, it behaves like a solid sphere because total mass is present inside it. Are you able to understand? And already we have studied that field because of a shell will be how much? 0 when point is inside the shell. Already we discussed, no? Are you able to understand? So this is a shell, no? Shell. And where is point R? Inside the shell or out of the shell? Inside the shell. So for inside points, field because of shell will be how much? 0. It means you need not consider the outer shell. Baitunna shell yokka effect point paina undadu. Therefore, no effect of gravitational field, no effect of outer shell at which point? At point R. Okay, ma? It means now you need to take field only because of the inner solid sphere. And for inner solid sphere, where is point P? Outside point, inside point, or on the sphere? On the sphere. For inside sphere, solid sphere, point R is present exactly on the surface. So make a note of that point also. For inside solid sphere, okay, ma? Point R is on its surface. Okay. Therefore, gravitational field because of inner sphere is how much, ma? It is equal to Gm dash divided by R square. That's all. It behaves like a point mass only, no? Which one behaves like a point mass? Inner sphere behaves like a point mass. And that equations already we have derived when point P is present on the surface of a solid sphere. What is the equation? Gm by R square. But above I have written Gm dash by R square. Because total mass is capital M. But I need to take only mass of solid sphere only, no? That mass is M dash. అర్థమవుతుంది కదా, రెండు ఫిగర్లుగా డివైడ్ చేసాము. బయట ఉన్న షెల్ ఆ పాయింట్ దగ్గర ఫీల్డ్ని ఇవ్వలేదు, ఎందుకు అది షెల్ లాగా బిహేవ్ చేస్తుంది కాబట్టి. But a solid sphere can definitely give gravitational field at point R because this point is present on the solid sphere. Are you able to understand? And we have to take which mass? We have to take only mass of solid sphere, inner solid sphere only. Because outer sphere cannot give any effect, no? So therefore its mass is M dash. So therefore what is M dash here? M dash is mass of inner solid sphere. Are you able to understand, ma? And can you say, how can I calculate M dash, ma? Take fractions of volumes, because mass is distributed in volumes, no? ఇది 2-dimensional body na 3-dimensional body na? 3-dimensional body. It has length also, height also, width also. Are you able to understand? Because this is a 3-dimensional body, volume mass is distributed in volume. Okay, so therefore do the calculation. So what is the volume of a smaller sphere? 4 by 3 pi small r cube. What is the volume of bigger sphere? 4 by 3 capital R cube. What is the total mass? Capital M. That's all, no? Okay. Now 4 by 3 pi, 4 by 3 pi get cancelled. So M small r cube divided by capital R cube. That's all, no? Now take this M dash and substitute here. Okay, ma? So if I substitute there, what is the equation I will get? Equation is, so gravitational field at a point R is equals to G M dash divided by R square. So G by R square multiplied by M dash is how much, ma? It is M small r cube divided by capital R cube. So R square and cube get cancelled. So gravitational field at a point R is how much, ma? So G M R divided by R cube. So this is the relation. Okay, ma? And same type of relation you will get in electrostatics also. Okay. Here the constant is G, no? There the constant is K. K value is 1 by 4 pi epsilon naught. Here I have small m into capital R, no? There I have capital Q into X, or R. Okay, ma? And R cube, there also R cube. Same relation. These relations allow electrostatics load exactly same relations. Once you understand this one, you need not understand electrostatics. Same equations. Okay, ma? That's it. So this is about gravitational field because of a solid sphere. So therefore for outside points and on the surface of the sphere, it behaves like a point mass. But for inside sphere, the equation is different. GMR divided by R cube. Okay? Therefore, if I draw a graph of gravitational field versus R, can you say how can I draw the graph? Okay, ma? So consider this is a solid sphere. Okay, ma? So this is the middle of the solid sphere, and this is the graph. Okay, ma? So on y-axis I am taking gravitational field, on x-axis I am taking R, and this distance is nothing but radius capital R, and that distance is capital R. Okay, ma? Now can you say, by looking at the equations, how can I draw the graph? Chappandi. So what is the gravitational field from center to surface? From center to surface, adi shellulo ka subaka 0, idi solid sphere idu. So it is GMR divided by R cube, nama? R is the distance from center. So if R value increases, G value also increases. Are you able to understand? R is a variable, no? Small r is a variable. Distance from the center is small r. So if R increases, G value, EG value also increases. So therefore, how can I draw the graph? How I can draw the graph is, I can draw the graph like this. From 0, it is slowly increasing. It means at the center, it is exactly 0. That's all, Rama. See, at center of solid sphere, R value is how much? 0. So substitute 0 here. So gravitational field at center is how much? It is 0. That's all, Rama. So field at center is 0. From center, it is slowly increasing in a straight line, because from center to surface, E is directly proportional to R. Okay? Now from surface, what is happening? From surface, it will decrease, because what is the relation? On the surface, it is Gm by capital R square, and beyond the surface, it is Gm by small r square. Okay? It means E is inversely proportional to 1 by R square. Surface nunchi taggali kada. So therefore, how can I draw the graph? Graph will be like this. Understood, Nama? And here, E is inversely proportional to 1 by R square. So again, where E value is maximum? E value is maximum at the surface itself. Are you able to understand? That's it. Okay, ma? So remember up to here. We will continue in the next class. Okay, same. So the next point is, the next body is ring. Okay. So gravitational field due to ring at a point on which axis? At a point on the axial line. What is meant by axial line, Sima? If this is the ring, this line will become axial line, no? This is the axis around which this ring can rotate. Okay, ma? So therefore, if I look at the ring from different direction, then this will become the axial line. Are you able to understand? Ring ki the axial line avutundi kada. So this is the axial line. Okay. So on this axial line, at a distance of x from the center of this ring, I want to calculate gravitational field. Are you able to understand? See, what I do is, I will take a small mass dm on this ring. Okay. So here I will take a small mass dm on the ring. Similarly, here also I will take a small mass dm, again exactly on the opposite point of the ring. Are you able to understand? So because of this dm, if I place any test mass m0 here, test mass is a point mass, no? And this small differential mass is also a point mass. The ring is not a point mass. This small mass and this small mass, they are point masses. So because of this point mass, this small mass, test mass, it experiences a force in this direction, no? It will experience gravitational force in this direction. Because gravitational force is always attractive force only, already we have studied, no? So therefore, because of this small dm, this point mass, it will experience a force in this direction. Then what is the direction of electric field, ma? Gravitational field will be in which direction? Definition we have already studied, no? E is equals to F divided by m0. This is the equation of gravitational field, no? Force experienced per unit test mass is nothing but gravitational field in that region. So therefore, what is the direction of F? Same will be the direction of E also. Because gravitational field is a vector quantity, it is not a scalar. Force is a vector quantity, no? So field is also a vector quantity. So what is the direction of force? Same will be the direction of gravitational field also. For field direction, I forgot to explain, Nama. So make a note here. Note point is that, so gravitational field is in the direction of, in which direction? Is in the direction of force experienced by point mass or test mass. Okay, ma? So in which direction test mass is experiencing force, gravitational field also will be in the same direction. Okay, ma? This is the force direction, no? And that is the direction of dE also. What is meant by dE, ma? What is meant by dE? Small dm will give a small force on point mass, no? So small force is given by dF. Because small force is acting, small gravitational field here is nothing but dE. That is the direction of dE. Are you able to understand? Okay. Similarly, I have taken one more point mass, no? One more differential mass. So because of this differential mass, so again what is the direction of small force, ma? This is the direction of dF, and say will be the direction of dE also. Okay. Now let us consider this angle to be alpha, or you can call it as pi. So this angle also will be pi only. Okay. Now split this dE into two components. Clear? This dE I will split into two components. Similarly, here there is one more dE, no? That dE also, where I will split, that dE also I will split into two components. Clear, no? What is the angle here? Chappali silent ga undakodu. Angle anta ikkada. Angle is pi. So what is the adjacent side? dE cos pi. Opposite side? dE sin pi. Okay, ma? Similarly, here also angle is pi only, no? This angle. So again adjacent side is dE cos pi. Opposite side is dE sin. Understood, no, ma? Now once you look into these two dE's, dE sin pi is in upward direction, dE sin pi is in downward direction. So this dE sin pi and this dE sin pi, they will get cancelled with each other, no? Ante kada? Are you able to understand, ma? So dE sin pi because of this small differential mass. Similarly, dE sin pi because of this differential mass, they are in opposite directions. This one is in upward direction, this one is in downward direction. So they will get cancelled with each other. But what about dE cos pi? dE cos pi are in which direction? They are towards the center of this ring. This dE cos pi and this dE cos pi, both of them, they are towards the center of the ring. So therefore, total E value, how can I calculate? Total gravitational field, how can I calculate, ma? So dE cos pi of all the differential masses you take. How many differential masses will be there on this ring? Many differential masses will be there, no? Okay, ma? So here there will be and oppositely, here there will be and oppositely, here there will be and oppositely. So like that many differential masses will be there. So therefore, total gravitational field, how can I calculate? dE cos pi plus dE cos pi plus dE cos pi. Okay, ma? Like this you can go on adding all the differential masses. And addition is nothing but integration. So therefore, total E value, how can I get my integration of dE cos pi? This is how I will get the integration. Are you able to understand? Now see. Now, what is dE? Listen very careful. dE is the gravitational field between this mass and this mass, or you can say gravitational field at this position. Okay. So let us consider this distance is r. Distance also I require. No? So this is the main mass here, dm. From the main mass, this point P is at how much distance? At a distance of r. Okay. Then what is the formula for dm? Gm by r square, no? Equation for gravitational field is gm by r square, because same equation for acceleration due to gravity also. So gm by r square. So g dm divided by r square. I can write like this, no? So substitute there. So therefore E is equals to integration of g dm divided by r square multiplied by cos pi. So I can get answer up to here. Understood, Nama? Then see, cos pi, how can I write? Cos pi is adjacent divided by hypotenuse. Which is the adjacent side here? This is the adjacent side, x. Opposite side is, hypotenuse is r. So therefore cos pi I can write x divided by r. So substitute that value there. Okay, ma? So therefore E value is how much? Integration of g dm divided by r square multiplied by x divided by r. So I got equation up to here. Okay. So therefore again what I will do, so g x r cube, they are constants, no? So take them out of integration. So E is equals to gx divided by r cube integration of dm. This is how I can write. So what is meant by dm? Differential mass. And what is meant by integration of dm? Addition of all masses. Integration means addition, already I said, you know. So if you add all differential masses, what you will get? You will get total mass of the ring. And what is the total mass of the ring? Capital M. Already I have taken, no? Capital M. So substitute here. So therefore E value is equals to, so G capital M x divided by R cube. I got relation up to here. Now what is R value? R value can be written as square root of x square plus R square, no? This is a right angle triangle, no? So R I will write in terms of distance and radius. R can be written as square root of x square plus R square. So therefore R is equals to x square plus R square whole power 1 by 2. But R cube is there, no? R cube is equals to x square plus R square whole power 1 by 2, no? This one 3 by 2. Okay, now? So substitute E value. So therefore how much I got? So gmx divided by R square plus x square whole power 3 by 2. Okay, ma? This is the equation to calculate gravitational field because of a ring. At which point, ma? At the axial point of the ring. Okay? Ring yokka axis paina x distance daggara meeku field kavalankondi, then this is the equation which I have to use. Have you understood, ma, how we have calculated? So gmx divided by r square plus x square whole power 3 by 2. That is the relation. Okay? So after that we will write one case now. Case is that at center of ring, okay, it means exactly at the center of the ring here, how much will be the gravitational field? And can you say anybody? On the axial line I have calculated the equation number. Center lo kavalante. At center x value will be 0, no? X is a distance from the center. But if you want at center only, then what is x value? 0. So if you substitute 0 here, then what you will get? Total value will be 0. It means exactly at the center of the ring, gravitational field will not be there. Gravitational field will be 0. Understood, no? So therefore, at center of the ring, I can write x value is how much? 0. Therefore, if you substitute in the equation, E is equals to gm into 0 divided by r square plus x square whole power 3 by 2, totally it is equal to 0. So therefore, what is the note point I have to write, ma? Gravitational field at center of ring center of ring is how much? It is equal to 0. Understood nama? Arthamatunda? Now see, again we will study reason also ma. Listen carefully, see ma. So this is a ring, you know? Ring. So consider I place one test mass exactly at the center of the ring. Ring madhyalo oka point mass ni place chesanu. Clear? Because of this dm, it will experience force in this direction. No? And because of opposite dm, it will experience force in this direction. So these two forces, they will get cancelled. No? Similarly, you take one dm here and one dm exactly in opposite direction. This differential mass, it will pull point mass in this direction. Similarly, here in this direction. Again, these two will get cancelled. It means every force is cancelled by dm which is present on the opposite side. So net force will become how much? That is why at the center of the ring there is no gravitational field. Gravitational field ledu ante arthamemi, gravitational force is also 0. Are you able to understand? That's the meaning of it. Is it clear, ma? Make a note. Okay, so therefore reason is what? At center, F net on point mass, net force on point mass is 0. Therefore, what is the equation for E? E is equals to F by m is also 0. That's it. Clear? So this calculation you have to practice 1 or 2 times, ma, and this equation you must by heart. Gmx divided by square root of r square plus x square whole power 3 by 2. Fine? Nothing. So on the axial line of the ring already we have calculated the equation number. E is equals to gmx divided by r square plus x square whole power 3 by 2. Okay? See, if you draw the graph of this ring from center r by root 2. Okay, ma? If I draw how this E value is changing with respect to distance, then the graph will be somewhat like this. Are you able to understand, ma? It means exactly at the center of the ring how much it is? At the center of the ring it is exactly 0. Already we have calculated, no? At the center of the ring E value is exactly 0. Now this is the distance where E has become maximum, no? Okay, ma? So E has become E max at this position. And if you calculate this distance will be capital R divided by root 2. Okay, ma? So therefore, that's why here we have written. So E will become E max when R will become R by root. It means at how much distance on the axial line field will be maximum? At a distance of R by root 2, gravitational field will be maximum. And it is that distance. So therefore, instead of x, what I can do? Instead of x, I can substitute R by root 2. So here also instead of x, I can substitute R by root 2. Then if I do this total calculation, then this is the value which I am getting. And this calculation you look for yourself. Are you able to understand, ma? So therefore, what is the maximum value of gravitational field on the axial line of the ring? Means this is the equation. 2gm divided by 3 root 3 into r squared. So this equation also you should remember, ma, can be asked in the examination. And at which distance it will be maximum? At x is equal to r by root. What is meant by x already we have studied, no? This distance is called as x. And when x will become r by root 2, then field will become maximum. Clear? Make a note of it. So this graph also you draw a graph of or graph between E and R. R means x in this condition. Instead of R I will write x. X means axial length on the axis of the ring. So the next body which we are studying is disk. So on disk also at which point we are studying on the axial line. So therefore on the axial line at a distance of x. So this is the equation of gravitational field. Okay, 2gmx divided by r square multiplied by 1 by x minus square root of 1 plus square root of r square plus x square. Understood, Nama? So here also we can do one point. At center of disk. Clear, Nama? It means exactly at its center, how much will be x value? X value will be how much? 0. Therefore, what is E value, ma? Here if you substitute 0, everything will become 0. No? So E value will become 0. So therefore exactly at the center of the disk also E value will be 0. And what can be the reason for this? Reason ఏమై ఉంటుంది చెప్పండి? Same reason what we have studied previously. So if you take one point here, or if you place a test mass here, okay ma? So this test mass will experience equal and opposite forces because of differential masses which are present on the opposite side. Clear no? So all the forces they will get cancelled with each other. Clear? They get cancelled with each other. Therefore, net force acting on the point mass exactly at the center is 0. So if force is 0, I can say gravitational field, which is equal to net force divided by m0, also will become 0. That's it. Fine, Nama? So these are the different bodies, at least which we have to study for NEET and mains levels. For advanced levels, there will be some more bodies which we are not discussing until now. Okay? That's it. Okay, ma? So these are some of the questions on gravitational field, ma? So see. So two particles of masses 9m and 16m, they are placed at a distance of d. Then find the position from 9m where gravitational field will become 0. That is the question. Clear, number? So here there is a particle of mass 9m, and at a distance of d, there is a particle of mass 16m. So what is the separation between them? Separation between them is d. So I have to find out that point in between these two masses where gravitational field will become 0. Okay? Can you say how can I proceed in this problem? How can I calculate that position where gravitational field will become 0? Gm by r square. No. So you go for the definition of gravitational field. What is meant by gravitational field? Gravitational field means what? Force experienced per unit test mass. This is the definition of gravitational field, no? Okay. It means that, for example, if I place any test mass in between these two masses, let this one be the test mass. Test mass means already we have understood, a very small mass is called as test mass. Okay. So if I place a very small test mass here, now this body will exert force in this direction, no? Let it be F1. Okay. Gravitational force is always attractive force only, no? Similarly, this body also will pull this test mass in this direction with a force of F2. Okay. Therefore, on the test mass, what is the net force, ma? Net force should become 0. Okay, ma? If net force becomes 0, then gravitational field also will become 0, because gravitational field is nothing but net force experienced by the test mass. Clear, no? If this test mass, if it is not experiencing any force, it means net force will become 0. Then at that point, gravitational field also will become 0. So definition wise, you should never forget the definitions. Everything you should solve according to definitions. Net force, if it becomes 0, gravitational field also will become 0. Now he is asking distance from 9m nama, so let us consider this distance to be x. Okay, I will call this distance to be x. Then what will be the remaining distance, ma? Remaining distance will be how much? D minus x. That's all, no? Because total distance he gave it is x. Now calculate gravitational field. Okay, ma? So gravitational field because of 9m should be equal to gravitational field because of 16m. Why gravitational fields they are equal? Because forces should be equal, no? Are able to understand, ma? So only when F1 and F2 when they are equal, then only net force will become 0. So if forces are equal, test mass is same, no? Same test mass. Forces are equal. Numerator is also equal, denominator is also equal. So gravitational field also will be equal. Clear, no? So therefore do the calculation. So gravitational field at m0 at a distance of x because of 9m is how much? What is the formula for gravitational field? Is equal to gm divided by r squared. This is the equation, no? Because of point mass. Substitute then. So g, mass of that body is how much? 9m. And what is the distance of that body from this point? X square. So this is equals to g. Now what is the mass of this body? 16m. Okay, divided by now what is its distance? D minus x whole square. That's all, no? So G, M will get cancelled. Now if you take square root on both sides, then it is 3 by x is equals to 4 divided by d minus x. So just to calculate x value from this one, that is my required answer. That's all. Understood now? Come on, make a note. I hope you can do this one, no, to the calculation. Here, gravitational field doesn't mean that both the gravitational fields, they are acting in opposite direction. No, they are not acting in same direction. They are acting in opposite direction. Already we discussed that the direction of force on test mass is the direction of what? Is the direction of gravitational field also. Okay, ma? So here force is acting in this direction, no? So because of 9m, gravitational field is also in the same direction. Because what is the equation for gravitational field? Force per test mass. So what is the direction of force? Same will be the direction of gravitational field also. So here equal doesn't mean that they are acting in the same direction. They are acting in opposite direction. Okay? So I can say that here on this body, this is the direction of E1. Okay, ma? On test mass, because of 9m, this is the direction of E1. And because of E2, because of 16m, which is the direction of E2, this is the direction of E2, in opposite direction. But magnitude-wise, they should be equal. Then only they can get cancelled with each other, no? Because force is a vector quantity, gravitational field is also a vector quantity. Okay, so write down. So, gravitational field should be, or fields should be equal and opposite. Okay, ma? Force is a vector quantity. Field is also a vector quantity. Okay? So, force ఏ డైరెక్షన్లో ఉంటుందో ఫీల్డ్ కూడా అదే డైరెక్షన్లోనే ఉంటుంది. Okay? If two forces acting at that point is 0, it means that gravitational field also will be 0. Net field is 0. It means both fields, they are equal and opposite. Similarly, if you want to write in vector form, you can write like this also. How I can write? E1 dash plus E2 dash should be equal to 0. Vector sum of both the fields should be 0. It means one is in one direction, another field is in opposite direction. Whatever it may be, magnitude wise, they should be equal, no? That's why we have written like that. Okay? So, two concentric shells, ma, they are not solid spheres. And what they are? They are shells. Okay? What is the mass of first shell? Mass of the first shell is m1, mass of the second shell is m2. And we are taking three distances. Concentric shells means inside one shell there is another shell. Able to understand? And at three different distances, I want to find out force acting on this mass of m. Okay, what is the mass we are placing? We are placing a mass of m at a distance of r1, at a distance of r2, at a distance of r3. Then this mass will experience how much force because of these shells. That is the question. Okay? Can you say how can I calculate? Come on. So when he says it is a shell, what you should remember immediately? Shell antune meekem gurtu ravali? Hollow sphere. Inka? The point which you should remember is, it behaves like a point mass. For which points? Outside points. On the sphere also it behaves like a point mass. When a point mass is present inside the sphere, that is the point which you should remember. Okay, ma? So gravitational field because of a shell, it will be 0. When there is any point inside the hollow sphere, that's what we have discussed now. Okay, ma? For example, if it is a shell, okay? So if I take this point, here gravitational field is not 0. Clear, no? Similarly, if I take on the shell, then also gravitational field is not 0. But if I take a point inside the shell, here gravitational field is definitely 0. So based on this logic, this question is framed. Are you able to understand, ma? Now let us see the first distance. So I will calculate the first one. Remaining two, will you calculate, ma? So force on m because of m1 and m2 at r is equal to r1. Okay, ma? Small r means what? Distance from the center is called as r, that's all. Three different r's are there. R1, R2 and R3. Now let us see. Now this point A it is external to both the first shell as well as second shell. No? It is outside first shell also, it is outside second shell also. So gravitational field because of any one shell is not zero. Because point A is external to both the first shell as well as second. Renditi byte undi kada idi. So therefore what I say that point A is external to both first shell and second shell. Clear now? Therefore, what is the gravitational field at a point A? This is it. No. Why it is zero? So it is gravitational field due to first shell plus gravitational field because of second shell. For example, if you place a test mass here, this test mass will experience two forces. No? It will experience force F1 also, it will experience the force F2 also. F1 is because of one shell, F2 is because of another shell. So both forces, they should be in the same direction. No? So gravitational field also will be in the same direction, because already we discussed what is the direction of force. That is the direction of field also. Force ఏ direction లో ఉంటుందో field కూడా అదే direction లోనే ఉంటుంది. So directly I can say that gravitational field at point A is the sum of E1 and E2. Is it clear, ma? Now do the calculation. So gravitational field because of bigger shell is how much? Bigger shell. What is the equation for gravitational field, ma? E is equals to Gm divided by R square. Okay. So G. Okay. Now which is my first shell? Outer shell is my first shell. What is the mass of first shell? M1. So G M1 divided by. Now from the first shell, what is the distance of this point A? R1. Every distance should be calculated from center only, no? So distance is R1. Clear? Plus gravitational field because of second shell. G M2 divided by R1. Distance is R1 only. From first shell also same distance, second shell also same distance, because every distance should be taken from the center itself. Okay, ma? Square we forgot. So therefore, I can do it as G divided by R1 square. If I take common, then it is M1 plus M2. So this is the net gravitational field because of both the spheres at point A. Okay. Similarly, can you calculate at point B and can you calculate at point C, ma? Come on, try to do it. So we have calculated gravitational field, no, ma? But what is the question he is asking? Force, gravitational force he is asking. So how can I do? That's it. So already we studied that gravitational field is equal to net force divided by mass, test mass. Are you able to understand, ma? So therefore, how can you calculate net force? Net force is nothing but gravitational field multiplied by test mass. So what is the gravitational field? Already we have calculated, no? G by R1 square multiplied by M1 plus M2. Multiplied by, which is the test mass? Test mass is small u. That's all. So this is the gravitational force acting on test mass at point A. Okay, ma? Once you calculate field, force very easily you can calculate. Okay. Similarly, calculate field at point B. Field at point B. Okay, ma? So B is inside bigger shell. Okay, ma? It is inside bigger shell, no? And outside smaller shell. Okay. Therefore, total gravitational field is E1 plus E2. So 0 plus E2. Why we are writing 0? Because field because of bigger shell will be 0. And bigger shell is my first shell. First shell, second shell. That's all, no? So do the calculation. So therefore, gravitational field is equals to, it is only because of smaller sphere. So therefore, G M2 divided by R2 square. This is the gravitational field at point B. Fine. And once I calculate field, force I can calculate, nama. So force is equals to M0 into E. This is the equation, no? F is equal to M0 into E. So substitute. So what is the test mass? Test mass is small m. And the field is how much? It is G M2 divided by R2 square. So that is the field at force at point B. Okay. Force acting on test mass at point B. Now can you say what is the force acting at point C? 0. Field is also 0. If field is 0, force is also 0. Why? Because point C is internal to both first sphere as well as second sphere. So point C, it is internal. It is internal to both first shell and second shell. Okay, ma? Therefore, gravitational field at a point C is equal to 0. Therefore, force at a point C is also 0. That's all. That is how we do the calculation. A ring of mass m and radius a, which is placed directly above a uniform sphere of mass m and equal radius. Okay, ma? So it means here there is a ring. This is a ring, ma? And what is the mass of the ring? Mass of the ring is small m. And what is its radius, ma? Radius is a. This is the radius of the ring. Okay. So it is placed directly above a uniform sphere and mass m and equal radius. Okay. So equal radius means what? So consider this is a sphere. Are you able to understand? Not properly drawn. Consider this is a sphere. Okay, ma? And what is its radius? Its radius is also same a radius, but its mass is capital M. This is the given data. Okay. Center of the ring is at a distance root 3a from the center of the sphere. It means, what is this distance? This distance is root 3 times of a. Distance between center of the ring and center of the sphere, it is root 3 times of a. Okay, ma? Then find the gravitational force exerted by sphere on ring. This sphere will exert how much force on the ring? That is the question. Okay. Anybody, can you say how can I calculate? Force exerted by... First you calculate gravitational field. Field multiplied by mass will give force. That's what we have studied, no? So we know that E is equals to F by M. Okay, ma? So therefore F is equals to M into E. This is the formula which we can adopt here. Okay. So therefore you can do one thing. You calculate field because of capital M on the ring. Or you calculate field because of ring on capital M. Or at the position of capital M. See, ma? Now see here, sphere is a spherical body, no? Sphere, what is the shape of the sphere? Sphere is a spherical body. Are you able to understand, ma? So therefore its total mass will be concentrated at its geometrical center, no? Total mass of the sphere will be always concentrated at its geometrical center. So what I will do is, I will calculate a field because of ring at the center of the sphere. So here what is the field? Because of what? Because of ring I will calculate. And once I calculate the field, okay, ma? If I multiply it by mass of this sphere, very easily I can calculate force exerted by the ring on the sphere. But what he is asking, find force exerted by the sphere on the ring. But what I am calculating, force exerted by ring on the sphere. Both are same or not? Definitely both will be same, no? Force exerted by sphere on ring is exactly equal to force exerted by ring on sphere. Both are same. Okay. But a calculation of this one is very easy. Force on the sphere by the ring is very easy. What is the reason? Because to this ring, this line will become the axial line. To the ring, what is this line? Axial line. Okay, ma? And already we have calculated a formula to calculate gravitational field because of ring when a point is present on its axial line. Already we have calculated. No? Are you able to understand? No. Field because of ring when a point is present on its axial line. Sphere we will consider as a point mass. Are you able to understand? Ma? Because already we discussed, ma, sphere always behaves like a point mass for external points. Are you able to understand? So therefore, we consider sphere as a point mass, where total mass is at its center. Clear, no? Okay, ma? This point mass is where is on the axial line of the ring. Axial line of ring. It is present on the axial line only, no, ma? Clear, no? So I can consider total mass of capital M is concentrated at its center. Understood, no? So therefore, gravitational field because of ring, what is the formula? Gmx divided by a square plus x square whole power 3 by 2. Already we have calculated this relation. Okay, ma? Field because of ring on the axial line is gmx divided by a square plus x square whole power 3 by 2. Now substitute the values. So g, what is the mass of the ring? Small m. And what is the distance? My x means the distance only, no? Distance of point P on the axial line is nothing but x. So x value is how much? X value is root 3 into a. So substitute. Root 3 into a divided by a. A means radius of this ring. Radius of the ring is a only. And again x value is how much? Root 3a whole square power 3 by 2. Okay, so just see what is the answer we will get. So root 3 gm into a divided by, so a square plus 3a square multiplied by 3 by 2. Clear, Nama? So root 3 gm into a divided by 4a square multiplied by 3 by 2. Okay, ma? So if I further do this calculation, so root 3 gm into a divided by g, small m or capital M? Small m only, no? So here we should not be confused because m represents mass of the ring here, not solid sphere. Okay, small m. So g small m into a divided by, so this I can write it as 2a whole square number multiplied by 3 by 2. So 2 and 2 get cancelled. So therefore what is the answer I will get? So root 3 g small m into a divided by, square if it get cancelled then it is 8a cube. This is what I will get. So again root 3 gm into gm a get cancelled, ma? So 8a square. This is what I will get. Understood, no? So that is the gravitational field because of a ring. At which position? At this position. Okay. And what will be the direction of gravitational field? Always attractive force, Nama? Force is attractive, so field is also in the same direction. This is the gravitational field. Okay. And at this point, this capital M is also present, no? What is meant by capital M? Mass of the sphere. So once you know that one, then can't you find out force, ma? Force only, no, he is asking. Therefore, F is equal to M into E. So F is equal to, what is the mass of sphere, ma? Capital M. Now capital M is the test mass here. Understood, no? Capital M behaves like test mass. Multiplied by E value. E value already we have calculated, no? So root 3 g small m into a is not there, no? Root 3 gm divided by 8a square. Okay. So therefore it is root 3 g capital M into small m divided by 8a square. So this is the force exerted by the ring on sphere. Okay. And same is equals to force by sphere on ring. Both are same, no? If earth is attracting apple with a force, apple is also attracting earth with same force. Newton's third law. Every action has an equal and opposite. So this is the question. So a tunnel is dug along a diameter of earth. Okay, ma? It means through the center of earth we are making a small hole. Tunnel means a hole is created. So find the force on a particle of mass m placed in the tunnel at a distance of x from the center of earth. So that is question I can say like this, na? So consider this is earth. Okay. And from the center of earth what we are doing? From the center of earth we are making a small tunnel. Okay, ma? So this is a hole which is made through the center of earth. Hole is made. Okay. So find the force on a particle of mass m placed in the tunnel at a distance of x from the center. Consider this is center. And somewhere here at a distance of x, okay, ma? If I am placing a mass of m, then we are supposed to calculate force acting on small m. That is the question. Okay. So consider mass of the earth is capital M and consider its radius is r. He didn't give that, we are assuming those values. Okay, ma? Anybody, can you say? This is earth, not hollow sphere. This is a solid sphere, no? Earth is a hollow sphere or solid sphere? Solid sphere. Then field cannot be 0, so force also cannot be 0. See the equations, see the formulae. So this is equal to, when a point is present inside the sphere, then what is the field? Already we have derived one equation also. Gm small r divided by capital R. That's it. Same, already we have studied. If this is the point where I want to find out a field, then enclosing this point, you have to draw a smaller sphere, no? That's what we have studied, no? Clear? Now this figure is divided into two parts. One outer shell and one inner solid sphere. That's what we have studied now. Force due to outer shell, it will be 0. And force because of inner sphere, it is not 0. Okay. So therefore, already we have calculated the equation when body is present at a distance of r from the center of the solid sphere. Okay. What is the equation? E is equals to GMR divided by capital R cube. This is the equation. Or GMX divided by capital R cube, anything we can say. Okay. And once we calculate field, force I can calculate by this method. F is equal to m into E. This is the relation. No? Now substitute. So what is the mass placed here? Small m. And what is the field at a distance of x? So it is G. And what is the mass of solid sphere? Capital M, GMX divided by R cube. That's all. So F is equals to G small m capital M multiplied by X divided by R cube. That's all. This is my answer. Are you able to understand? Very simple. Come on. Tunnel was dug from center of the sphere. Now what he is doing is, he is digging a tunnel from not from the center, at a distance, at a perpendicular distance r by 2 from Earth's center. Okay, ma? So let us see first of all what is the figure we can draw. So consider this is Earth. Are you able to understand, ma? And this is the center of Earth. Okay. And tunnel is dug at what distance? Tunnel is dug at a distance of r by 2, perpendicular distance. Therefore, it means that this is the tunnel which is dug. Understood, no? So without drawing clear diagram, you can never understand at this stage. Okay. This is the tunnel which is dug. Now again what he is saying, wall of the tunnel is assumed frictionless, there is no friction. Find force exerted by wall on a particle of mass m when it is at a distance x from the center of the tunnel. So definitely this will become the center of the tunnel, no, ma? So from here at a distance of x, okay, ma? So this distance is x. So here there is a mass of small m. That's the question what he is asking. No? So what is the force exerted by what? Force exerted by wall on this particle. So wall of this tunnel, it will exert some force on this mass. Why it will exert force? That did you think first of all? So if I release this ball, I think it should go downwards. That's what we assume. But he is saying tunnel is exerting some force on the mass. How? Because mass is also exerting some force on the tunnel. Newton's third law, no? Every action has equal and opposite reaction. Clear, no? Sima, whatever may be the position of this mass, force is always towards the center of the sphere only, no? This will be the direction of force. Understood, no? So if this angle, if I call to be angle theta, clear, no? Then this force, I can split into two components, no? Okay. So this is F cos theta and this is F sin theta. Are you able to understand? So what is this F cos theta? This is the force exerted by the mass on the tunnel. We are splitting force into two components, no, ma? Are you able to understand? Force direction is in this direction. This is the direction of force. Are you able to understand? We are splitting this one into two components. Okay. Adjacent component is F cos theta. Opposite component is F sin theta. If you take angle theta here, this will become F cos theta. This will become F sin theta. But I am taking angle here, no? So this will become F sin theta. This will become F cos theta. So therefore, what is this F cos theta? Force given by mass on the tunnel. Only in perpendicular direction only it can give force, no? Then tunnel will do what? Tunnel will give equal and opposite force. So that is magnitude of force given by the tunnel is also F cos theta. Are you able to understand? So therefore what we write? Force on mass by the earth only, no? By earth is always towards center. Is always towards center. Okay, ma? It means it is this force. Force is always acting towards the center. And that force, if I divide into two components, clear, ma? Then F cos theta is the force applied by what? Applied by mass m, mass small m on the tunnel. On the tunnel. Because with the help of F sin theta, mass cannot apply force on tunnel, no? F sin theta is in downward direction. But which force I am taking? F cos theta is the force which is applied by the mass on the tunnel. Therefore, equal force will be applied by whom? Applied by tunnel on mass m. That's all, Nama. Newton's third law. Every action has an equal and opposite reaction. Clear? Okay. Now to calculate force, what is the equation we have studied? F is equal to m into E. This is the equation. So it means first of all you are supposed to calculate E value. Okay. Now this point mass m, it is present inside the sphere, no? Is it outside the sphere, on the sphere, or inside the sphere? Inside the sphere. Inside the sphere means, again, if you draw a small sphere, this is outer shell and this is inner solid sphere. So force because of outer shell is 0. Force because of only inner shell will be present. And for that one already we have calculated the real relation, Noma. So gravitational field, what shall I call this point? I call this point as point P. Okay, ma? So field at point P is how much? So gmx divided by, I will write small r. So this distance if I consider to be r, okay, ma? So gmr divided by r cube. This is the formula, no? Already we know this formula, no, ma? But what is r value, do I know? R value I don't know. This is R value, not this one or this one. ఏది R value అది ఫస్ట్ మీరు అర్థం చేసుకోవాలి. So distance from center of earth to the point where this mass is present, that distance is called as R here. Okay. So how can I calculate R value? R by 2 is given, X is also given. You know Pythagoras theorem, no? Don't you know? Then apply. So R is equals to square root of R by 2 whole square plus X square. So this is my R value. Are you able to understand, ma? So we will substitute R value there. First of all, let us calculate the force here. So therefore force is how much, ma? Force is m into E. What is the mass of this test mass? Mass of this test mass is small m. E value is how much? So gmr divided by r cube. Let us keep it aside up to here. Let us not substitute. Okay? Because the force exerted which I want is F cos theta, no? I don't want F, I want F cos theta. Therefore, F cos theta value is how much? F into cos theta can be written as adjacent side divided by hypotenuse, no? Cos theta adjacent by hypotenuse. So adjacent is r by 2 divided by hypotenuse is r. Now you calculate. Therefore, F cos theta is equals to, F value already we have calculated, no, ma? So both are small m and capital M, this is capital M, no, sorry. So G capital M, this one. Mass of earth is capital M. Okay, ma? So G capital M into small m into R divided by R cube multiplied by cos theta. Cos theta value is R by 2 divided by R. So R and R will get cancelled, no? That's why I did not substitute R value, because they are getting cancelled with each other. Therefore, F cos theta value is how much, ma? So 1 and R, 1 cube also will get cancelled. So G capital M into small m divided by 2 into R square. So this is my answer. Okay, ma? So that is the force exerted by the mass on the tunnel. Then tunnel also will give equal and opposite force on the mass. That's it. అసలు ఏమన్నా ఉందా క్యాలిక్యులేషను? డయాగ్రామ్ వేయడంలో తప్పు చేస్తున్నారు. ఆవేశం, ఆతృత అనమాట. డయాగ్రామ్ కరెక్టే. ఈ క్యాలిక్యులేషన్స్ అంతా చేసినావా? చేయనప్పుడు ఎందుకు పని లేక డయాగ్రామ్? కొంచెం అంటే ఇదంతా చేసి చెప్పినావు నువ్వు? మర్డర్ చేస్తాను నేను.